Good evening, students. Class 2 or second period. Now is the coordination compound. The last class, so we discussed what is coordination entity, what is meant by central metal atom, and what are ligands and its classification. Now the second class, so I can discuss coordination number. I can discuss what? Coordination number. Now I can discuss what? Coordination number. What is this coordination number? Coordination number is defined as the number of ligand attached to what? Attached to central atom. The number of ligands attached to central atom or ion is called what? Coordination number. What is coordination number? The total number of ligands, or it is defined as the number of ligands attached to central atom or ion is called what? Coordination number. So one more definition is there. Total number of coordinate bond. Total number of coordinate bond between ligands and metal atom or central metal atom, so it is called what? Coordination number. But this the first definition, it is applicable only for what? Monodentate ligand. For example, so here I can write Pt and Cl4. So this is what? -4. So here how many ligands are attached? 4 ligands are attached. So coordination number of Pt is platinum is 4. Okay, yes. And here for example CO, next is what? NH3, and it is what? 6, and it is what? +3. So how many ligands are attached? Total 6 ligands are attached. So coordination number of cobalt is 6. So what is the coordination number? The coordination number is defined as the number of ligands or the number of ligand donor atom is attached to central atom or ion is called what? Coordination number. Yes, here 4 chloride ligands are attached. The coordination number of platinum is 6. Here 6 ammonia ligands are attached, so coordination number is 6. But this the above definition is not applicable for what? Bidentate ligand. For example, I can take this is what? FeC2O4. Okay, this is what? -3. Okay, this is what? -3. Okay, so I can write here. So here the total oxalate ligands are attached to iron is 3, but coordination number is not 3, because in case of bidentate ligands, so we can apply the definition, the total number of coordinate bond between ligand and what? Metal. So here, so for example, here is a bidentate ligand. So C2O4 is a bidentate ligand. The C2O4, it contains how many donor atom? 2 donor atom, and total so the C2O4, it contains 2 donor atom. Total ligands attached is 3. So 2 into 3, it is called what? It is called what? 6. 6 is the coordination number. It means, so the above the definition is applicable for what? For monodentate ligand. So the number of ligands equal to coordination number. But in case of bidentate ligand, the number of ligands is not equal to coordination number. So you have to multiply donor atom with what? Number of ligands. So we can get what? Coordination number. So here for example, one more example I can discuss here. So this is what? Cobalt. So what is the En? En is nothing but a ethylene diamine. So En, and it is what? +3. This is what? +3. So here what is the coordination? So according to this first definition, the number of ligand attached to the central atom is called coordination number. But this definition is not applicable because ligands attached are 3, but coordination number is not 3 because En is a bidentate ligand. It has how many donor atom? 2 donor atom, and you have to multiply 3, so it gives what? 6. So 6 is the coordination number. So the coordination, the total ligands attached to the platinum 4, so coordination number is 4. Here the total ammonia ligands attached to the cobalt, so 6, so coordination number is 6. But here number of ligands attached to the iron is 3, but coordination number is not 3 because C2O4 is a bidentate ligand. C2O4, this is a bidentate ligand, and it is how many donor atom? 2 donor atoms. So that's why I have to multiply it with 3, so it gives what? 6. Coordination number is not 3, coordination number is 6. So it means so this above the definition is applicable for what? The above definition is applicable for example 1 and example 2, and this total number of coordinate bond between the ligand and central atom is applicable for what? Applicable for example 3 and what? Example 4. So the example 1 and example 2. The example 1 and according to example 1, what is the definition? The number of ligands attached to central atom or ion. So 4 ligands, coordination number 4. 6 ligand, so coordination number is 6. But here ligands attached are 3, but it is a bidentate ligand. It has 2 donor atom, 2 into 3, coordination number is 6. So ethylene diamine is also bidentate ligand. Donor atoms are 2, 2 into 3, it is a 6. So it is called what? Coordination number. So next is this is the coordination number is over. The next I can discuss here. The next I can discuss coordination polyhedron. So coordination polyhedron. The second one is nothing but a coordination polyhedron. Coordination polyhedron. Okay. So what is this coordination polyhedron? So in this coordination polyhedron, so we can discuss here coordination polyhedron. So what is this coordination polyhedron? Okay, what is the definition? The spatial arrangement. The spatial arrangement of what? The spatial arrangement of what? The ligand. The spatial arrangement of what? Ligand. The spatial arrangement of what? Spatial arrangement of what? Ligand donor atom. The spatial arrangement of ligand donor atom directly bonded to or directly attached to central atom defines what? Defines coordination polyhedron. Coordination polyhedron. Is it correct or not? So the spatial arrangement of ligand donor atom directly attached to central atom or ion, it defines what? Coordination polyhedron around what? Central atom is called what? Coordination polyhedron. So most common coordination polyhedrons are: one is tetrahedral, one is what? Tetrahedral. The second one is what? Square planar. The second one is square planar, and the third one is what? Third one is what? Octahedral. Third one is what? Octahedral. So here, so these are the three most common used coordination polyhedron. So for example, I can take here one example. I can take CO. This is what? NS3 6. CO NS3 6, and this is what? Plus 3. So what is the coordination number? Cn means what? Coordination number is 6. So what is the polyhedron? Coordination polyhedron is octahedral. Coordination polyhedron is octahedral. And next I can next example I can take what? Ni. So this is what? Cl4. NiCl4. This is what? -2. So what is the Cn? Cn means coordination number. Coordination number is 4, but coordination polyhedron is tetrahedral. This is what anybody? Tetrahedral. And the next example I can take NiCN4. This is what? NiCN4. This is what? -2. So what is the coordination number? Coordination number is 4, but it is a hybridization is what? DsP2. So hence it is a square planar. Hence it is a square planar. So these are the coordination polyhedron. The examination. So what is meant by coordination polyhedron? The spatial arrangement of ligand donor atom. So directly attached to what? The central atom or ion. So which defines what? Coordination polyhedron. So around the central atom, the most common coordination polyhedrons are: one is tetrahedral geometry, second is square planar, and the third is what? Octahedral. So here, now I can write here, this is the complex. So the 6 ammonia ligands are attached to cobalt. So coordination number is 6. It is octahedral. Here 4 chloride ligands. 4 chloride ligands are attached to nickel ion. So hence it is a tetrahedral geometry. And here 4 cyanide ligands are attached to the nickel. So coordination number is 4. So it is a square planar. Yes. The next I can discuss coordination sphere. Coordination sphere. What is this coordination sphere? It is a part of coordination compound. It is a part of coordination compound. What is a coordination sphere? It is a part of coordination compound. And it consists of central atom. It consists of central atom and the ligand is bonded to it. Ligand is bonded to it. Okay, what is the coordination sphere? Coordination sphere is a part of the coordination compound, and it consists of central atom where ligands are directly bonded to it or attached to it. So this is called what? Coordination sphere. And in a coordination sphere where metal atom, central metal atom or ion and ligands are enclosed in a square bracket. So this is what? Coordination sphere. It is a part of the coordination compound and it consists of what? Central atom where ligands are directly bonded to it, means central atom, and the central metal atom and the ligands are enclosed in a square bracket. So it is called coordination sphere. And next is what? Here one more is I can discuss ionization sphere. So this ionization sphere is also called counter ions. Ionization sphere is called what? Counter ions. Ionization sphere is called what? Counter ions. Is it correct or not? Yes. So first I can write here. So what is this counter ion? It is a ionizable group. Written outside the square bracket. So it is called what? Counter ions. Coordination sphere is a part of the coordination compound where the ligands and the central metal atom is enclosed in a square bracket. Next is the ionization sphere, or it is also called what? Counter ions. It is an ionizable group. It is always written outside the square bracket. Example. So in K4FeCN6, this is what? K4FeCN6. This is the complex. This is a K4FeCN6. So it gives what? 4K plus and plus of what? FeCN6. Cn6 and F is Cn6 minus 4. So this K plus is called counter ion. This K plus is called counter ion. This K plus is called counter ion. And this is total, the square bracket is called what? Co-ordination sphere. It is, the square bracket is called what? Co-ordination sphere. So in a complex K4 Fe6, this K plus is written outside the square bracket, so it is called what? Counter ion. And this is the central atom and the ligands are enclosed in a square bracket, so it is called what? It is called what? Co-ordination sphere. This is the example 1. Now the second example. Now I can discuss what the second example. This is the second example, cobalt. This is what? NH3. Okay, this is what? Anybody? NH3. And this is what? Okay, NH3 6. And next is what? Cl3. This is what? Cl3. So now it dissociate. It gives CO. This is NH3. And this is what? 6. And this is what? Plus of what? 3Cl minus. So here this is called what? Square bracket. The square bracket is called coordination sphere. It is called coordination sphere. Coordination sphere. And the Cl minus is called what? Counter ion. So here this square bracket in a complex, the ligands and the central metal atom were enclosed, it is called coordination sphere. Outside the square bracket, that is called what? Counter ion or ionizable group. So this is called what? Coordination sphere and what? Counter ions. So this is now coordination sphere is over, counter ion is over, and next is coordination polyhedron and the coordination number is over. The next is the homoleptic and heteroleptic complex. So before going to the homoleptic and heteroleptic complex, so I can discuss what? Complex ion. Very important. Complex ion. What is this complex ion? Complex ion is defined as it is a electrically charged radical. It is a electrically charged radical. Electrically charged. What is a complex ion? The complex ion is defined as it is a electrically charged radical. Electrically charged radical means either positive charge or negative charge. On the basis of this charge, the two types of ions are there. One is complex cation. One is complex cation. What is this complex cation? The complex ion having a positive charge. Example, I can take Cu. This is what? NH3, and this is what? 4, and this is what? Plus 2. So this is called complex cation. So this total coordination entity or the coordination sphere having a positively charged, so it is called what? Complex cation. One more example is CO. This is what? NH3, and this is what? 6, and this is what? Plus 3. So this is called complex cation. So the next is what here? Next one is complex anion. One is the complex anion. What is this complex anion? So I can write Fe Cn6. Okay, Cn6. This is the minus 4. And next is what? Fe. Now it is C2O4. Okay, C2O4. And this is what? Minus 3. Next is what? AgCN. Next is what? AgCN twice. This is what? Minus 2. So these are nothing but a complex anion. So complex ion means they are electrically charged radical, either positive or negative. If coordination entity is positive charge, it is called complex cation, or if coordination sphere it is having a negative charge, so it is called what? Complex anion. So on the basis of the complex cation and the complex anion, the complex compounds are classified into three types: cationic complex, anionic complex, and neutral complex. Next I can go for complex salt. Next I can go for complex. The complex compounds are three types. Okay, the complex compound. Complex compounds are three types. They are further classified into three types. First is complex compounds are cationic complex. Cationic complex. What is this cationic complex? What is this cationic? Very important. What is this cationic complex? The cationic complex complex is is one which contains complex ion have having having positive charge when the complex is said to be cationic complex. The cationic complex is defined as the which contains what? One complex ion, at least one complex ion having what? Positive charge. Okay, I can explain. See here. So I can take one example. Cationic complex. CO, this is what? NH3, and this is what? 6, and this is what? Cl3. Okay. So this is cationic complex because in this cationic complex CO, NH3, and it is 6, and this is what? Plus 3, and now it is what? 3Cl minus. So this is called cationic complex because in this cationic complex which contain at least one complex ion having a positive charge. Suppose if square bracket is on left, so it is called cationic complex. The first is coordination pair, next is counter ion, it is called what? Cationic. How to identify? First is coordination pair, next to coordination pair is counter ion, so it is called cationic complex. Otherwise, so this is Cl is negative and coordination pair is positive, no doubt it is a cationic complex. Okay, the next example I can take here. The next example. So here, one more example I can take here. This is what? CO. This is what? En, and next I can write here. This is what? Cl3. So now I can. So right here, which is Cl is what? Negative. Cl is negative means. So now this is what? E, N thrice, and plus of 3, and this is what? 3Cl minus. So this is what? This cationic complex contains at least one complex cation having a positive charge, so it is called what? Cationic complex. So one more example, Cu, and this is what? NH3, and this is what? 4, and this is what? SO4. So this is an example of what? Cationic complex. Why? So this is Cu, and next it is NH3, and this is what? 4, and what is the charge? The charge is plus 2, and this is what? SO4 minus 2. What is a cationic complex? The cationic complex is one which contains, or the cationic complex contains at least one complex ion. It contains at least one complex ion having a net positive charge, so it is called cationic complex. In the first example, so this is the charge is what? Positive, so hence it is called cationic complex. In the second example, so the coordination pair or the coordination entity is what? Plus 3, so or plus, so hence it is called what? Cationic complex. So in the example, the cuproammonium sulfate, it is called cuproammonium sulfate. In this cuproammonium sulfate is a cationic complex. It contains at least one complex ion having a positive charge, so that's why this complex is an example of cationic complex. So otherwise, how can you identify? Cl is minus, so the square bracket is positive, so cationic complex. So here SO4 is what? Negative. Already we know that SO4 is negative, so the square bracket is what? Positive, no doubt, so it is a cationic complex. Otherwise, if a square bracket is first, next is counter ion, so it is a cationic complex. The way of what? Identifying the cationic complex. So the next is what here? So this is the cationic complex is over. Next is what here? Ion-ionic complex. Next is ion-ionic complex. Very important. So this is the first is cationic complex is over. Next, second one is ion-ionic complex. Number 2, ion-ionic complex. So what is this ion-ionic complex? Okay, the anionic complex which which contain one complex ion have have net negative charge. Net negative charge is called anionic complex. Cationic complex, it contains at least one complex ion having a net positive charge. Here having a net negative charge. For example, I can take one example, K4. Yes, this is a K4. I can write Fe. This is the Cn6. Okay, K4 Fe Cn6. Correct or not? Now, so now it is dissociated, gives 4K plus of, now I can write here Fe Cn6. This is what anybody? This is minus 4. See here, K4 FeCN6 is an anionic complex. Why it is called anionic complex? In this complex, it contains one complex ion. This complex ion having a negative charge, so that's why it is called what? Anionic complex. So one more example, I can write here K2. This is what? NiCl4. K2 NiCl4. Oh, okay, K2 NiCl4. So what is this anybody? 2. This is what? K plus of Ni. This is what? Cl4. And next, what is the charge? Minus 2. So K2 NiCl4 is a anionic complex because in this anionic complex it contains one complex and this complex ion having what? Negative charge. So otherwise, how can you identify? K plus is positive, square bracket is negative. It is an anionic complex. So here K plus is positive. So NS, the square bracket is negative. So it is called what? Anionic complex. One more example. Na3. So this is F oxalate. I can write OX and it is what? 3. Yes. So now I can write here. So this is, now what is this? 3Na plus of FeOX thrice. This is what anybody? Minus 3. This is what? Minus 3. Is it correct or not? Yes. This is what? Minus 3. So I can write here Na3FeO. So here I can write. So Na is what? Positive. Automatically square bracket is negative. Square bracket is negative means, or coordination pair is negative means it is a anionic complex. So in this complex, so this coordination pair or this coordination entity, so or it is complex and having a negative charge, so it is called anionic complex. What is meant by anionic complex? Anionic complex is one which contains at least one complex ion having what? So you take any complex, there must be one complex ion. If complex ion is negative, so it is an anionic complex. Here you say this is a complex, so the complex ion is negatively charged, so anionic complex. So in this complex, so this complex ion is negative charge, so it is anionic complex. So in this complex, Na3FeOX OX thrice. So in this complex, so FeOX thrice minus 3, it is a complex ion is negative, charge, so hence it is called what? Anionic complex. Otherwise, how can you identify? Simply, yes, K is positive, so coordination, K counter ion is positive, coordination pair is negative, anionic complex. K is positive and square bracket is negative, anionic complex. Na is positive and automatic coordination pair or complex ion is negative, so it is what? Anionic complex. So this is the way of what? Identifying the cationic complex and anionic complex. So the next I can go for neutral complex. Next I can go for neutral complex. So what is this neutral complex? Yes. So now I can go for neutral complex. So the first one is cationic complex. The second one is anionic complex. The third one is neutral complex. Third one is neutral complex. So what is this neutral complex? Question number. So what is this neutral complex? So this neutral complex, the complex, it does not have charge, does not have any charge, either no positive or no negative. For example, I can take here. So no, so next is for example NiCO4. Yes, it is a neutral complex. Why it is neutral complex? It doesn't have any charge, no positive charge, no negative charge. It is a neutral complex. So CO, this is what? Cl3. Next is what? NH3 thrice. So this is what? This is called what? Neutral complex. So how can you identify neutral complex? There is no counter ion. If counter ion is absent, there is no counter ion. So whether it is a positive counter ion or negative counter ion, there is no counter ion. It is a neutral complex, or it doesn't have any charge. So it is called what? Neutral complex. So this is a cationic complex is over and anionic complex is over. So I can discuss. So another example I can discuss. Okay. So I can discuss here. So this is K2 and next it is what? PT, and this is what? Cl4. This is one example, and next example I can take here. Next example I can take, this is what? K3, and next is Ni, and this is what? Cn4, and one more example I can take here. For example, same example once again, NiCO4, or otherwise other example I can take here, FeCO5s. So how can you identify cationic, anionic and neutral complex? Okay. So here simple method is the counter ion is K. K is plus. K is plus. So square bracket is automatically negative. So square bracket means coordination pair is negative. So it is a anionic complex. It is a anionic complex. Simple method. Next here, which is the counter ion? Okay. So here, which is the counter ion? Yes, K plus is counter ion. So it is a negative, square bracket is negative charge. So it is also anionic complex. So the next is what here? So the next one more example I can discuss here. Now I can take here Cu, and next it is what? NS3. Okay, NS3, and next is what? Next is what? NS3, and next it is what? Water. Okay, next it is what? SO4. Yes, it is a SO4. So what type of complex here? So here you see, which is the counter ion? SO4 is the counter ion. Here SO4 is what? Negative. SO4 is negative. So coordination pair is what? Or complex ion is what? Positive. So no doubt it is a cationic complex. It is a cationic complex. Cationic complex. So one more next example. I can go for FeCO5. FeCO5. Okay. FeCO5. So here no counter ions. Counter ions are absent. No positive counter ion, no negative counter ion. So hence it is called. Hence it is called what? Neutral complex. Hence it is called what? Neutral complex. So this is the way of what? Identifying the cationic, anionic and neutral complex. So this is the last part of this class 2. Homoleptic and heteroleptic complex. Homo means similar, hetero means different. What is this homoleptic complex? The homoleptic complex is defined as where metal atom or central. So homoleptic complex is defined as where central metal atom is bound with what? Bond with what? Only same kind of what? Only same kind of what? Same kind of what? Donor group, or same kind of what? Ligand. Same kind of ligand or same kind of donor group. Okay, so this is called what? Homoleptic complex. Same type of ligand. I can write CONH3. This is what? 6, and this is plus. Yes. So same kind of ligand is bonded to central atom, or same kind of what? Donor group is bonded to what? Central atom. It is called homoleptic complex. Next, one more example. Fe. This is what? CN6, and this is what? -3. So or -3, -4 are two examples are there. So it is called here only one kind of donor group or only one kind of ligands are attached. So it is called what? Homoleptic complex. So the next is what here? Next is the heteroleptic complex. So here the heteroleptic complex is defined as central atom or ion is bond with more than more than one kind of donor, more than one kind of what? Donor group, more than one kind of what? Donor group. So it is called what? Heteroleptic complex. It is called what? Heteroleptic complex. So homoleptic complex, the central metal atom is bound with only or bonded with same kind of donor group, where the central atom or ion is bound with more than one kind of donor group. It is called what? Heteroleptic. Otherwise, same ligands are same type of ligand is attached to the central atom, homoleptic. Different kinds of ligands are attached to the central atom is called heteroleptic club, heteroleptic complex. So now I can read CO, this is NH3, this is 4, and this is what? Cl2, and this is what? Cl. So two kinds of donor atom, one is nitrogen donor, one is chloride donor, or different kinds of ligands attached to central atom is called what? Heteroleptic complex. So one more example I can take Cu, and next is what? NH3, NH3, okay, and next is what? Anybody? Next I can take here, I can take what here? Is cobalt I can take here. Yes, this is the CO, and this is what? Cobalt. Cobalt is a central atom, CO, and next it is what? NH3 4, and next it is the water, and twice, and it is what? Cl. Same. So both are neutral ligand. Oxidation state of cobalt is +3. Okay. So here the donor atom is nitrogen. Here donor atom is oxygen. Here donor atom is chloride. Here donor atom is different donor or more than one kind of donor or different ligands are attached to central atom is called heteroleptic complex. Same kind of ligands or same kind of donor groups is attached to central atom is called what? Homoleptic complex. So this is the second class we are discussing today. What is the coordination polyhedron? What is meant by coordination number? Types of complex and complex ion. Next is the homoleptic and heteroleptic complex.